What if you could turn your app idea into production ready product in minutes? With OpenAI new O series models, this is now possible. Let me show you how. In this video, I will demonstrate how the O1-Mini model can generate production ready code for a financial trading app with event driven microservices. But first, let's talk about what makes the O series unique. OpenAI already has a GPT family of models, so why the new O series family models? Is it better than the GPT family model? The answer is that one model family isn't better than the other, they are just different. We can use them differently for different needs. O series model are special because they think step by step. The O series automatically does this, unlike GPT models, which need extra prompts to reason through problems. This is thanks to the reinforcement learning, which trains the model to solve problems more like a human would. This means the O series model will help us to generate great output with less context and promptness than the GPT or the other models. On the other hand, it will take a high cost and latency due to the internally using reasoning tokens and a chain of prompts. Think of O series as a luxury car. It's a powerful and precise, but it comes with a higher price tag. While GPT models are reliable sedan, great for everyday tasks, the O series is built for complex, high stakes problems. O series science in field like science, engineering, and finance, where the precision is critical. For instance, it can generate an accurate code for a trading app or solve complex equation. But for the simpler task, GPT is still your best bet. We are here to use O1 model for the coding task. I have written a blog with detailed information and code for generating the trading app. Let's gear up for the same. I have written this blog cranking the code how OpenAI's O1-Mini outshines GPT-4 in trade processing on the Medium. You can find the link in a post or the comment sections. Let's first discuss variations of the O series model. It comes in three categories. O1 is the main reasoning model best suited for complex tasks requiring broad general knowledge, including function calling and image input. O1-Mini, a faster, cost-efficient reasoning model best suited for coding, math and science. It is designed for most cost and latency sensitive use cases. O3 Mini, this is the most recent and cost efficient model in O series. It delivers exceptional STEM, science, technology, engineering, and mathematics capabilities while maintaining the low cost and reduced latency of OpenAI O1 model. In this blog, we will use O1 Mini, not the O3 Mini, because my account still don't have access for O3 Mini. I have written a O model use cases. Here are the two use cases that we will use in this block. Creating a code with high level design. So in this block, we will generate the code for our trading app. The second one is the evaluation and benchmarking for other model responses. Here we will evaluate the output of O1 Mini and GPT-4 Mini models using the O1 Mini models. Now let's see the O series magic. The idea here is that we will have the high level design of the trading app and we will draft a prompt and run that prompt with two models. One GPT model and another one is the O model. We will use O1 Mini model from O series model and GPT-4o Mini, a lighter version optimized for efficiency and cost effectiveness. For running this code, first we integrate the Chat GPT and O series model into our application using the Chat API provided by OpenAI. We must register with OpenAI and get the API key to access the API. If you see, this is the code for setting up the OpenAPI key. And then we have written one more helper function which show the formatted code output in Jupyter Notebook. Now this is our trade ordering app. In a trade app in financial industry, it allows user to buy, sell and manage financial instruments such as stocks and bonds. At the heart of this app, there is a microservice architecture where we have a different microservices which pushes the events to the Kafka, and they normally talk each other using some kind of enterprise service bus which sends event to the bus like Kafka. This kind of architecture provides scalability, reliability, and speed in modern trading apps. If you see here in the diagram, we have a three app written in different languages. One is Node.js, another one Python, and third one is again Node.js. Order service, risk service, and execution service. We will tie them together into the event-driven architecture using Kafka. We will ask the model to write stubs for Kafka and producer and consumers, where we can add our business logics later. If you see here, we have writing a prompt. In a prompt, if you see, we have mentioned three services: order service, risk service, and execution service. These will be written in Node.js and Express. Risk service will written in Python and Fast API, and execution service again Node.js and Express. I have mentioned which service will use database and how which service will use in-memory database like Redis. I also mentioned the please generate the Kafka production and consumers, but don't implement actual business logic. So now let's run this prompt first on the GPT-4 model. Once I run this on GPT-4 model, I got the generated code here. If you see, it generated nice order service, then risk service, and the third one is the execution service. These all it has generated. So it generated three nice and clean microservices providing endpoint to the orders. It also provides code for reading and writing from the Kafka bus, but many items are missing, like the database integration code, inability to provide any infrastructure setup for Kafka and Docker, and the lack of mention of memory caching, error handling a asynchronous operation. So it generated the code, but still more of the things are missing from the production point of view. So now let's run the same trade prompt on O1-Mini model. Let's see what it generated actually. So now you have noticed it has not generated 3 code blocks. In it generated 11. Now the order service has the package.json elaborating its dependency. It's also integrated code for PostgreSQL and suggested schema and SQL queries also. In the same way, it generated the requirement txt for Python risk service and integrated Redis for the memory risk book. It also has generated a Docker file including all components. If you notice block 10, it gives a bash script for setting up the Kafka with all the required topic. It seems like O1 has set up many components for start our microservices. So if you go through this code, it may be generated next time when you run it, may be some different, but it will be on the similar line only. So now one more thing which we can do, we can have a evaluation through the O1 model for both the output which we have received from GPT-4 and O1. So now if I run and I ask O1 again, which code is better and why? Option 1 is the GPT-4 and option 2 is the O1 code. I use some markdown format to show in good manner. And now if you see here, the output is option, it says in a one line, option 2 is generally better than option 1 for several reasons related to scalability, maintainability, best practices, and completeness. And it gives a full summary on where it is already doing. It gives around on set 7 or 8 point on which it actually evaluate both the models. So now if you see the option, it says if you are building a production ready trade order management system or any other system that requires reliability, scalability, and maintainability, option 2 is the preferred choice. So now option 2 is winner. So what do you think? Would you use the O series model for complex tasks or GPT for everyday needs? Let me know in the comments. And don't forget to check out my blog for more detail. You can also go through the code which is there on my public Git repository. Both links you can find in the description. Thanks.